Okay, so a big focus today was how to sketch rational functions now that we have practiced finding key features a lot. So we're going to start by making a list of the key features of this function. Okay, key features. So let's start with, I don't know, where do we want to start? X-intercepts. So we say we have an X-intercept. Okay, we're going to look over here for what's going to make this output 0. And what makes the output 0 is when you do 0 divided by something non-zero on bottom. So we're looking for a factor that's only on top, and x minus 1 is only on top, so we have an x-intercept then at 1, 0. All right, and then we notice that there is a x plus 2 factor on top and an x plus 2 factor on bottom. So that means we must have a whole at -2. Now to determine the x value, the y value of that, we're going to plug that into the rest of the factors. So let's just sidebar over here really quick, or here, I'll do it down here. So we do 6 times -2 minus 1 divided by 3 times -2 plus 1 times -2 minus 3. All right, so what does that give us? 6 times -3 is -18 on top. And then look at that 8. And on bottom, we have 3 times -1 is -3 times -5 is +15. So just over 1, we have a whole at -2, -18 over 15. Okay, so then looking back at our function, we have vertical asymptotes. Those happen on bottom because if you divide by something increasingly close to 0, then your output gets increasingly large. So we have some VAs at x equals -1 and at x equals 3. Okay, I'm going to look at the degree of the top compared to the bottom. So I have a degree 2 on top, degree 3 on bottom, so the bottom's going to become way bigger, and if we're going to divide by an increasingly larger number, that's going to approach 0. So we have an HA at y equals 0. Last thing, we want to find a y-intercept. The y-intercept is just the value when we haven't moved horizontally at all, so we're saying x is 0. So all we have to do for that is plug in 0 for x. So we get 6 times -1 because we plugged in 0 for x, and we don't have to do the 2, so we have 6 times -1 on top, and then we have 3 times 1 times -3 on bottom. What is that going to give us? Don't need this big line over here. Okay, what is that going to give us? It's going to give us -6 over -9, which is going to simplify to 2/3. So we have the y-intercept at 0, 2/3. Okay, so now when graphing this, we're going to put all of these key features onto a set of axes. We've already labeled all of them, so they're already labeled here, so we don't have to be super precise on our graph. We're just making a sketch. So I'm going to put an x-intercept at, where I'm going to call 1, 0. All right, let's make this a black point. Okay, 1, 0. Okay, looks like we have a hole at -2 about -1. So we're going to put a hole there at -2, about -1. There's our hole. All right, we have vertical asymptotes at -1 and 3. So let's put those in. -1 and then 3. Okay, horizontal asymptote is on the x-axis at y equals 0. Okay, and then the y-intercept is at 0, 2/3, 0, a little bit less than 1. Okay, we'll just say that's about right there. That's fine. Okay, so all of our key features are on the axes now, and now we should be able to graph this. Because when we look at this left section, we have a hole down here, so the function must be happening down here because it has to hit this hole at some point. And we also notice that it doesn't cross the x-axis anywhere here because there's no x-intercept over here. We only have the x-intercept right here. So because that doesn't happen, we must only exist down here. We have to approach our horizontal asymptote this way, and then we're going to go down to -infinity this way. So we know that in this section, the graph must look something like this. It's going to hit the hole. It's going to disappear for just the hole. Okay, so there we go. Looks like that. Now in class, we talked about how if a vertical asymptote has a multiplicity of 1, so x plus 1 has a multiplicity of 1, so does x minus 3, then the graph is going to approach different infinities on either side of it. So we're approaching negative infinity on this side. We must be approaching positive infinity on this side. The other thing that points our attention to that is the fact that we have to go through this 0. We have to go through the y-intercept. There's no way that we can go through the 0 and go through the y-intercept and not go to positive infinity. If we were to go to negative infinity, we would have to cross the x-axis again, which doesn't happen. We only cross it once. So that tells us that this part must look something like this. And then using the same reasoning, we have to approach a different infinity on this side of the asymptote. We can't go down to negative infinity because the multiplicity is 1. So we're going to approach infinity from this side. We also have to approach the horizontal asymptote from this side. And again, noticing we're never going to cross the x-axis because there's no x-intercept. So that tells us on this side we must look something like this. Okay, and this is a real rough sketch on the iPad. So then there's our sketch. So what you need to make sure you understand is, and this was covered in the lesson, why, when the multiplicity is odd, do the asymptotes, on either side of the asymptote, we approach different infinities? Why is that the case? And then there was also a Desmos activity that we did in class that everyone should do, because that's going to help you do another problem on the problem set. So I'm going to put the codes at the bottom of this video right now. You can review the video, review that Desmos activity, review the lesson, and you should be good to go. All right, there are the codes. So if you want to go to student.desmos.com and type in the code that goes with your class, you can go through that activity. And yeah, that was just the bell. We're about to start 4th period. Here we go.